Hey guys, I just wanted to come on and talk a little bit about entropy really quick. So entropy is our measure of the disorder of a system, or another way to word it is it's the measure of the randomness of a system. Okay, so on the left side over here, if this whole left side of the screen was my system, which is just whatever we're looking at, whatever we're studying, okay, these circles over here are in a nice pattern, they're lined up really nicely, so they're very ordered, which means there's not much randomness, which would mean that we have a low entropy over here. If we look at the system on the right side of the screen, these circles, there is no pattern, there is no really structure, okay? So that has a high randomness, which is going to mean we have a high entropy, okay? So again, we look at these couple dorm rooms here. This one on the left would be really low entropy, right? Everything is organized, everything is in its place, okay? Nice and neat, low entropy. The one on the right, okay, a lot more messy, everything's all over the place, it's super random, doesn't look like there's any sort of organizational system, okay? That would be really high entropy. Now, we have our law of disorder, which says that if you leave a system alone, it's always going to increase its entropy. Okay, and if you think about it, if you have your room, a room here, and if you never put any energy into keeping it clean, eventually it's going to look like the one on the right over here, right? If you don't put any energy in to keep it neat, it's going to become messy. Okay, same thing with your locker at school. If you don't put work in, put energy in to organize it, it's going to become more and more chaotic and crazy. Same thing goes for all natural processes in the universe. So over time, unless you're putting energy into a system, its entropy will increase, and that's our law of disorder. When we are talking about chemical reactions, if we have a chemical reaction where the entropy increases, so it gets more random, more disordered, that reaction would be favored, okay? So that's going to push it towards being spontaneous. Now we have a few ways that chemical reactions can increase the entropy, can increase in entropy, okay? First one deals with states of matter. So we have our three states of matter. We know how the particles in those states move, okay? Solids, those particles are really packed together, they're just vibrating, they're not moving around much. That's going to be low entropy. You can pretty much tell where a solid particle is going to be. It's not going to move. Not very random, low entropy. Liquids, okay, they're going to be able to move around a little bit more, right? They can slide past each other, but still not too much. So that entropy is going to be kind of in the middle. And our gases, okay, those particles, right, are flying all over the place. They're running into things. They're bouncing off of things. Super random, super disordered, very high entropy. Okay, so any kind of chemical reaction we have where we started with solids and we formed liquids or gases, our entropy increased. If we started with liquids and we end up with a gas, okay, our entropy increased in that chemical reaction. So if we're going to the right across this screen in our chemical reaction, we increased our entropy, and that would favor the formation of our products. Okay. Second way has to do with the number of particles. Okay. If we can have more particles, it's going to be more random, more disordered. It'll have a higher entropy. So in this case, we're looking at something dissolving. If I have a solid in a liquid, okay, maybe it's a chunk of salt in some water, when that salt is all together, that's going to have a low entropy. I know where that salt is. Okay, it's right there in a little chunk. Low entropy. If it dissolves, now I have a lot of little pieces of salt all the way through my water, okay? Which means there's a lot more places there could be salt, it's a lot more disorderly, it's a lot higher entropy. So anytime we're breaking something down into smaller pieces, and that happens in any kind of chemical reaction, that would also increase our entropy and would favor the formation of products for that reaction. Our third way, okay, deals with the number of molecules that we have in a chemical reaction. So this is the electrolysis of water. So we start with 2 water molecules, and we end up with 2 hydrogen molecules and a molecule of oxygen. So we've broken down these 2 water molecules, and in our products we have 3 molecules. And if you think about it, over here we only have 2 things. So there's only so many ways they can be arranged, right? I have 2 things, I can flip their spots, but really there's only so many ways they can be arranged. If I have 3 objects, now there's more ways I can arrange them. And if there's more ways I can arrange them, that means there's going to be more disorder. It's more random. Okay, so it's a higher entropy. So anytime we have a chemical reaction where we have more molecules of products than we do of reactants, that's going to increase our entropy, and again, it will favor the formation of my products. And our last way deals with temperature. Okay, so this goes back, we know that temperature is a measure of the average kinetic energy of particles, right? The higher the temperature, the faster those particles are moving. Okay, we know that. So if we have a low temperature, these particles are moving around, but the slower something moves, okay, the less random it is, right? If you think about, you put a bunch of people in a gym somewhere and have them, if they're walking around, it's easier to guess where they're going to be in a little bit if they're walking than if they're, a bunch of kindergartners who got free at recess and are now sprinting around the gym. Okay, so if we heat something up, if our chemical reaction increases in temperature, or if we add heat to our chemical reaction, it's going to increase our entropy. And again, that is going to favor or push the reaction in favor of the products and forming those products. So we're going to end up taking into account entropy and enthalpy to figure out if a reaction is spontaneous enough, but these are 4 of the ways that we can increase our entropy to try to make a reaction be spontaneous.